In this video, we are going to learn about multiplying polynomials. Now, if you remember in the past, we talked about polynomials being made up of monomials that are separated by addition and subtraction. So today we're going to learn a method that I've used for a long time on multiplying polynomials. So we'll just start with a couple of examples for you to try and to see. So let's look at starting with, let's do 3x minus 2 times x plus 7. So we have two binomials. They are binomials because each has two terms. So if you remember back when you first learned how to multiply numbers and you were given a chart for your multiplication tables, a lot of times the way the charts were set up is you would have a grid, and along the top would be, say, 0 or 1 through 12, and along the side would be 0 or 1 through 12. And we're going to use the same idea. In this case, instead of 0, 1 through 12, I'm going to use my binomials. So each term gets its own space on the grid. So across the top, I'm going to put 3x, and then in the second box, minus 2. And along the side, I'm going to use x and plus 7. I could have done vice versa. It doesn't really matter. But like the grids that you learned in elementary school for your multiplication tables, if I use my fingers to follow along, it'll tell me which two pieces I need to multiply together to get each box. So the 3x and the x, if I were to use my fingers to follow along, they would fill in this box. So I would do 3x times x, which gives me 3x squared. For the farther box is x and the minus 2. X times negative 2 is negative 2x. And so on and so forth. So the 3 comes down here with the 7 to give me 21x, and then the 7 and the negative 2 to fill in the last box of negative 14. So once I have this all filled in, I can combine my like terms. The only like terms I have are the negative 2x and the 21x. So writing my terms in descending order of power, I have 3x squared. 21x plus negative 2x gives me 19x, and then minus 14. Let's try another one, and then I'll have you try a couple. Let's do 2x squared minus x plus 4 times 3x minus 1. So in this case, I have a trinomial, 3 pieces, by a binomial with 2 pieces. So my grid then, I'm going to have 3 spaces across the top and 2 across the side. So I've got 1, 2, 3, and 1, 2. So I've got the top is 2x squared minus x and plus 4, and the side is 3x minus 1. So again, following each of the boxes, I've got 3x times 2x squared. 3 times 2 is 6. X times x squared gives me x cubed. Now this one is going to be negative x and the 3x, so it's going to give me negative 3x squared. And then the 4 and the 3 is going to give me 12x. That's my top row. My bottom row is going to be negative 1 times each of the pieces. So that's going to give me negative 2x squared. Negative 1 times negative x gives me positive 1x. And negative 1 times 4 gives me negative 4. Now that I'm all filled in, I see that I have some x squareds in common and some x's. So I'm going to go in descending order of highest power, starting with my 6x cubed. Then I'm going to combine negative 3x squared plus negative 2x squared gives me negative 5x squared. 12x plus 1x gives me plus 13x. And last but not least, minus 4. I'm going to At this point, you'll see a pop-up screen for the one that I'd like you to try. You can also do this with a monomial. So for instance, if I had 3x times 4x squared minus x plus 2, we've learned in the past to use the distributive property, but you could also technically use the same thing we've been doing, except you'll have a 3 by 1. 1, 2, 3 by 1. So I'm going to put the 3x here and the 4x squared minus x plus 2. So 3x times 4x squared gives me 12x cubed. 3x times negative 1x gives me negative 3x squared. And 3x times 2 gives me positive 6x. So I've got 12x cubed minus 3x squared plus 6x, which I would have gotten the same thing had I used the distributive property.